You know, have you ever really stopped to think about what a kilogram is? It sounds so simple, right? But that one little unit of measurement is actually the first step on this incredible journey, one that takes us from a basic physical object all the way to the digital world that we all live in now. So today, we're going to explore how humanity went from just agreeing on reality to actually coding it. So let me ask you this. How do you know that a kilogram in Seoul is the exact same as a kilogram in New York? I mean, really think about it. It seems like a simple question, but the answer, wow, the answer is literally what makes global science, international trade, and yeah, even the internet possible. It all boils down to one thing, a shared agreement. It's like we all decided to use the same universal rulebook for reality itself. All right, so let's dive into our first section, a world of measurement. And yeah, that rulebook we just talked about, it all starts right here. Before we can do any of the cool, complex stuff, from building a skyscraper to launching a satellite, we first have to agree on the basics. We have to be able to describe the world around us in a way we all understand. So at its very core, what is measurement? It's really just this simple act of slapping a number on things. You take something kind of fuzzy and subjective, like heavy or far, and you turn it into cold, hard numbers. Heavy becomes a very precise 10 kilograms. Far becomes exactly 5 kilometers. This is the language of science and engineering, and honestly, it's the absolute foundation of everything we built. But, you see, for my 5 kilometers to mean the exact same thing as your 5 kilometers, we need that shared agreement. We need a universal rule book for how we measure things, and that's where this whole idea of a standard comes into play. So, what exactly is a measurement standard? Well, think of it as our shared official definition for a unit, the official meter, the official kilogram. Without these standards, every single measurement would just be a wild guess, and the modern world, it simply couldn't exist. No way. And you can really see this in action if you look at the evolution of the meter. It's a fascinating story. Way back in the late 18th century, they tried to tie it to the size of the Earth. Then, around 1799, they made an actual physical bar and basically said, this is a meter. But here's the problem with physical objects, right? They can change, they can get damaged. So in 1983, we took this huge revolutionary leap and defined the meter by something truly universal and unchanging, the speed of light. And it wasn't just the meter. This incredible shift is happening with all our core measurements. The second is now tied to the super precise vibration of a cesium atom, like a tiny, perfect clock. And the kilogram, the one we started with, it's not a lump of metal in a vault anymore. Now it's defined by a fundamental constant of quantum physics. We've moved from relying on physical stuff to relying on the very laws of the universe. It's a huge deal. Now, I know, we're talking about atoms and the speed of light. This might all seem really abstract and scientific, but these standards have a massive impact on our daily lives, often in ways that literally keep us safe and healthy. I mean, just think about it. You see a speed limit sign? That's a standard in action, helping prevent accidents. You get a fine dust alert on your phone? That's based on a precise measurement that protects your health. A heat wave warning on the news? That's another standard telling you to stay safe. Even something like regulating construction noise, it's all based on this shared language of safety that protects us every single day. Okay, so we have our universal rulebook for measurement. That's step one. But how do we actually use it to capture information from the world around us? Well, the next challenge is to translate nature's signals into a language our technology can understand. Our world is just filled with signals. Light from the sun, the sound of your voice, the heat from a fire. Most of these signals from nature are continuous, constantly flowing and changing. We call these analog signals. An analog signal is like a perfect flowing wave, a precise replica of what happened. But it has a huge weakness. It's fragile and super easy to distort with noise. A digital signal, on the other hand, breaks that wave down into a series of numbers, basically on or off, 1 or 0. It's a coded approximation, but its great strength is that it's incredibly robust. You can copy it 1,000,000 times, send it around the world, and it stays perfect. So how do we cross that bridge from the analog world to the digital one? The answer is the sensor. It's this remarkable little device that can feel an analog signal like temperature or light and translate it into an electrical signal that our technology can understand and process. So, this journey from nature to data is one of the most fundamental processes of our modern world. An event happens, the temperature goes up. This creates a continuous analog signal. A temperature sensor detects this change and converts it into a digital value. And just like that, a physical feeling becomes a piece of data we can store, analyze, and act on. And once we learn how to turn our world into digital code, everything changes. The potential becomes nearly limitless. And this is the magic number of the digital age: 0. That's how much information is lost when you copy or transmit digital data. You get a perfect copy every single time. It's a complete game changer. And this incredible power has totally reshaped our society. It's revolutionized how we manage money with digital banking, how we learn through online education, how we get around with self-driving cars, and even how we get healthcare through remote surgery. It's all possible because we can turn the physical world into perfect digital information. So we started with a simple question about a kilogram and ended up here, in a world literally running on digital code. The journey from just agreeing on measurement to digitizing reality has been astonishing, which leaves us with a final fascinating question to think about. With this immense power to measure and code our world, what problems should we solve and what future should we build next?